This presentation will be about converting from base 10 to base 2 and from base 2 to base 10. To go from base 2 to base 10 is almost easier than base 10 to base 2. First, write out the place values. When first learning, you might use cards with zeros and ones on them and place them above a strip of paper with the place values written on them. In base 2, 1001 is 18 and 11, meaning we're doing 8 plus 1, which means 9. So this 1001 means 9 in base 10. That's pretty easy. It's a little harder to go the other way. If we make the base 2 number for 18, 14, and 11, it's easy if we know the place values. It's 1101. In base 10, we would say this number is 13. What would this be in base 10? You need to know the base 2 place values. Write them out if you need to. After a while, you'll just know them. 1111 in base 2 is 15 in base 10. Consider why we shouldn't call 1111 in base 2 1111. Let's just call it 1111 base 2 instead, because if we use those 1111 labels, it means we're actually misidentifying the place values. That's not 1111. What if we want to convert 95 in base 10 to base 2? This is much easier if you have the place values written out. Obviously, there is no 128. You can only have one at most of each place value. There is a 64, so we put a 1 in the 64 place value. 95 minus 64 is 31, so we don't have enough left over for 32, so we put a 0 in that place value. We put a 1 in 16, and now there's 31 minus 16 left, which is 15. So we put a 1 in the 8. Now you have 7 left, because 15 minus 8 is 7. That's a 4, a 2, and a 1. So we can just put a 1, 1, 1 in the 4, 2, and first place value. After a while, you start to notice patterns that make this less tedious. For example, you'll notice that all the 1s up to a place value add to 1 less than that place value. For example, when I saw that we had 31 left, I already knew that there would be a 0 in the 32 place values and that all the ones after that would be 1. Software engineers just end up knowing the base 2 numbers as well as we know base 10 because they work with computers.